Take the radius of the Earth to be 6.371 kilometers. What is the orbital velocity of a satellite that's 420 kilometers above the surface of the Earth? So we have a couple of things here. We have the radius of the Earth, but that's not how far the satellite is from the center of the Earth, because we have to add these, right? Kilometers plus 421 kilometers to get to the total radius. So let's start there. R the Earth, distance to orbit, right? So we got 6371 kilometers, 421 kilometers. And so the distance of this satellite from the center of the Earth is the sum of those two, which I can use the sum function. All right, now we need this, though, R in meters. So R in meters is just 1,000 times R in kilometers. Now we have R in meters. 6792,000 meters. The equation for orbital velocity is what? It is the square root of mg over r, right? If you need to find that, it should be at the top of the homework. V orbital, gm over r, mg over r, same thing, right? mg over r, where m is the mass of the Earth, g is the universal gravitational constant. G, I do remember off the top of my head, 6.67 times 10 to the minus 11 newtons meters squared per kilogram squared. Mass of the Earth, let's go find that. Mass of the Earth, 5.97 times 10 to the 24th. All right, so mass of the Earth is 5.97 times 10 to the 24th kilograms. Double check my memory real quick. Yep. So we know mass of the Earth, we know G, and we have R, and we just need to calculate this. Orb is square root of. All right, lots of parentheses. 6.67. I'm going to leave out the units to make my life a little bit easier. Minus 11. More parentheses. Times 5.97 times 10 to the 24th. All right, all of that divided by 6792000. So that's what we have to calculate. Well, let's hop over to Excel real quick. All right. G is 6.67, and remember for Excel, you e the minus 11 to get times 10 to the 11th, times 10 to the minus 11th. Mass of the Earth, 5.97 e 24. All right. So now we have V orb. Orbital velocity is the square root of G times m divided by radius in meters. 7,656.9, we'll call it 7,657 meters per second. 7,657 meters per second. That's the orbital velocity at that height above the surface of the Earth. And that's it for this problem.